Good morning, my dear students. Welcome to the discussion on the subject Engineering Graphics. Under Engineering Graphics, we are going to discuss a topic on development of surfaces. Under development of surfaces, we are going to solve a problem on radial line method. This is the fourth solved problem we are discussing under radial line method under the topic of development of surfaces. Now we will enter into the problem. The given problem is a pentagonal pyramid of base side 30 mm and axis 60 mm long rests on its base on the HP with a side of the base parallel to the VP. It is cut by two section planes which meet at height of 20 mm from the base. One of the section plane is horizontal and cuts the left side of the axis of the pyramid, while the other is inclined with an angle of 45 degrees to the HP and leaning upwards right side of the axis of the pyramid. Draw the development of the lateral surface of the truncated pyramid. This is the pentagonal pyramid and it is resting on its base on HP such that one of the base sides, say BC, is parallel to the VP. This pentagonal pyramid is cut by two section planes which meet at a height of 20 mm from the base, and one of the section plane is horizontal and cuts the left side of the axis of the pyramid, while the other is inclined with an angle of 45 degrees to the HP and leaning upwards right side of the axis of the pyramid. Now we will write the data. The name of the object to be developed is lateral surface of the truncated pentagonal pyramid. The base side length of the pentagonal pyramid is 30 mm, axis height is 60 mm, and this pentagonal pyramid is resting on its base on HP such that one of the base sides, say BC, is parallel to VP. This pyramid is cut by two section planes. The first section plane is parallel to HP and perpendicular to the VP, passing through the axis at a distance 20 mm above the base and cuts the left side of the axis of the pyramid. Second section plane is passing through the axis at a distance 20 mm above the base and making an angle 45 degrees to the HP and leaning upward right side of the axis. Here, our objective is to develop the lateral surface of the truncated pentagonal pyramid. For that, as a first step, we need to draw the true shape of the base of a pentagonal pyramid. The first step in projection of solids is to draw the true shape of the base. Here, the pentagonal pyramid is resting on its base on HP and one of its base side is parallel to VP. So, the true shape of the base of a pentagonal pyramid is visible in top view. That is, the true shape of the base of a pentagonal pyramid is regular pentagon that is visible in the top view. So, draw true shape of the base of a pentagonal pyramid in top view with one of its sides, say BC, is parallel to the vertical plane. That means while drawing the top view, we need to draw side BC parallel to the XY line and construct the regular pentagon. Say BC and its length is 30 mm and complete the construction of the regular pentagon. After that, locate the center point of the base of a pentagonal pyramid. That center point is nothing but the image of the apex of a pentagonal pyramid. O is the image of the apex in the top view. Then join OA, OB, OC, OD, OE. Here OA, OB, OC, OD, OE are nothing but slant heights of a pentagonal pyramid. Here OA, OB, OC, OD, OE are the images of slant heights in the top view. With this basic information, we'll enter into the detailed construction of the development of lateral surface of a truncated pentagonal pyramid. The following detailed steps are considered for the development of lateral surface of a truncated pentagonal pyramid. The first step is to draw top view as well as front view of the pyramid. Second step is to draw section plane lines with the given conditions. Third step is to draw development of the lateral surface of the truncated pyramid. Now we'll enter into the detailed construction for the development of the lateral surface of the truncated pentagonal pyramid.
Here, the pentagonal pyramid is resting on its base on HP such that one of its base side is parallel to VP. In this position, we need to draw top view as well as front view of the pentagonal pyramid. As a first step under drawing top view as well as front view of the pentagonal pyramid, draw XY line. Here, the pentagonal pyramid is resting on its base on HP such that one of its base side is parallel to VP. So, the top view of the pentagonal pyramid's base is a regular pentagon with one of its side is parallel to the XY line. Here, the base side length of the pentagonal pyramid is given in the problem as 30 mm. So, with 30 mm as a base side length, draw base side of a pentagonal pyramid, then complete the construction of the regular pentagon with this base side length. The interior angle between two adjacent sides of a pentagon is 108 degrees. The pentagon A, B, C, D, E is the image of the base of a pentagonal pyramid in top view. Then we locate the center of the base of a pentagonal pyramid. That center will become the image of the apex point as well as axis point in top view. Here, O is the image of the apex as well as axis in top view. In order to draw images of the slant edges in top view, we will join the points say OA, OB, OC, OD and OE with straight line segments. This is the top view of the pentagonal pyramid when it is resting on its base on HP so that one of its base side is parallel to the vertical plane. Then we will move towards drawing the front view of the pentagonal pyramid. For that, we will draw projector through the points say A, B, C, D, E and O towards the vertical plane. First we will draw projector through O point towards the vertical plane in order to locate the apex point. Here the height of the axis given in the problem as 60 mm. So name this point as O dash. Then draw projectors through A, B, C, D and E points towards the XY line. For drawing the front view, the observer is looking in this direction. For the observer, the face edges say OA, OB, OC, OD are visible and the face edges say OE is invisible. So, we will join the points say O dash A dash, O dash B dash, O dash C dash, O dash D dash with continuous line and O dash E dash with dotted line. And also the base edges say AB, BC, CD are visible for the observer. So join the points say A dash, B dash, B dash, C dash, C dash, D dash with continuous line. Here the height of the axis is 60 mm. This is the required top view and this one is the required front view when the pentagonal pyramid is resting on its base on HP with one of its base side is parallel to VP and axis parallel to VP. Till now, all the lines are drawn with 3H pencil. That is, all the lines drawn in front view as well as top view are with 3H pencil. That means these lines are thin lines. Now we'll see what do you mean by true length of the slant edge. Here, the image of the slant edges say O dash D dash in top view is not parallel to the XY line. O dash C dash image in top view is not parallel to the XY line. O dash E dash image in top view is not parallel to the XY line. O dash B dash image in top view is not parallel to the XY line. O dash A dash image in top view is not parallel to the XY line. So none of the face edges in the front view are called true length of the slant edges. So in order to convert these face edges into true length of the slant edges, we need to rotate the image of the slant edge in top view parallel to the XY line. Through O, draw a line parallel to the XY line. Then with compass, O as a center, OD as a radius, draw an arc on this parallel line and name this point as D1. Through D1, draw a projector onto the XY line. Name this point as D1 dash. Then join O dash as well as D1 dash. This is also thin line that is with 3H pencil. Here this O dash D1 dash line is called true length of the slant height. Why it is called true length of the slant height? Because its image in the top view is parallel to the XY line. Now we will draw section planes. There are two section planes. The first section plane is perpendicular to VP, parallel to HP and passing through the axis at a distance 20 mm from the base and it cuts the pyramid left side of the axis. So locate a point at a distance 20 mm from the base. And the section plane is parallel to HP and perpendicular to VP and it cuts the left side of the pyramid. After that, another section plane is there which is making an angle 45 degrees to the HP and perpendicular to the VP and it is passing through the axis at a distance 20 mm from the base and it is leaning upward direction in the right hand side. With both the section planes, we are cutting the pentagonal pyramid. So with that, we are going to remove the material above the section planes and we are going to use the material below the section planes for development. Then we'll draw the lines below the section planes for the development purpose. Next step is locating the intersection points of the section planes with the face edges of a pentagonal pyramid. Here, the first section plane is cutting the O dash A dash face edge at 1 dash, and section plane is cutting the O dash B dash face edge at 2 dash, and O dash C dash face edge at 3 dash. O dash D dash face edge cuts the section plane at 4 dash, and O dash E dash face edge is cut by section plane at 5 dash. Here O dash A dash, O dash B dash, O dash E dash, O dash C dash, O dash G dash are not called true length of the slant heights, whereas O dash D dash is called true length of the slant height of the pyramid. So transfer the section plane as well as face edges intersection points onto the true length of the slant height by drawing horizontals through these points. Through 1 dash, 2 dash, 3 dash, 4 dash and 5 dash, draw horizontals onto the true length of the slant height. Next step is drawing the development of the part P portion of the lateral surface of a pentagonal pyramid. For that, we are going to use radial line method. Then draw a line parallel to XY line passing through O dash. After that, locate a point O with true length of the slant height, say O dash D1 dash as a radius, O as a center. Draw an arc. Then name this point as A. With A as a center, base side of a pentagonal pyramid, say 30 mm as a radius. Draw an arc on this arc. Then name this point as B with B as a center with the same radius, say 30 mm. Draw an arc. Then name this point as C with the same radius. Draw another arc. Name this point as D with D as a center with the same radius. Draw an arc is E with the same radius. Draw an arc, with that you will get point A. So name these points as A, B, C, D, E, A. Make a note, OA is the radius of the true length of the slant height. Then join A to B, B to C, C to D, D to E to A points with straight line segments, and O to B, O to C, O to D, O to E and O to A points are also with straight line segments. Here AB, BC, CD, DE and EA are the base sides of a pentagonal pyramid. OA, OB, OC, OD, OE and OA are the face edges of a pentagonal pyramid. With this we completed development of the lateral surface of pentagonal pyramid without section planes. Here OA, OB, OC, OD, OE and OA are called true length of the slant heights in the development. Then with O dash 1 dash as a radius, O as a center, draw an arc on OA slant edge, because 1 dash is the intersection point on O dash, A dash, that's why this point becomes 1. Similarly, O dash to 1 dash also with the same radius. So with O as a center, the same radius, draw an arc on OB slant edge. Name this point as 2. Phi dash on O dash E dash slant edge. So O dash phi 1 dash also with the same radius. So O as a center with the same radius, draw an arc on OE slant edge in the development. Name this point as 5. Then O dash 3 1 dash as a radius, O as a center, draw an arc on OC slant edge in the development, because 3 dash is the intersection point of section plane with OC slant edge. Then name this point as 3. Then O dash 4 1 dash as a radius, O as a center, draw an arc on OD slant edge. Then name this point as 4. Then O dash 1 1 dash as a radius, O as a center, draw an arc on OA slant edge and name this point as 1. Then join the points, say A21, 122, 223, 324, 425, 521, 12A, A2E, E2D, D2C, C2B, B2A with continuous and dark lines with H pencil. Also dark part of the face edges of the pentagonal pyramid, say 2B, C3, 4D and 5E with continuous dark lines with H pencil. Now we'll see the pencil usage details. Here the part P portion containing lines in the front view are with H pencil, remaining lines are with 3H pencil and dimensioning is with 2H pencil. And in the case of development, the pink color lines are with H pencil and remaining lines are with 3H pencil, dimensioning is with 2H pencil. In the case of dimensioning, here the base side length of the pentagonal pyramid is 30 mm, axis height is 60 mm. The section planes are meeting the axis at a distance 20 mm from the base of the pentagonal pyramid. That is, all the dimensions are in millimeters. For drawing the arc in the development, we need to take true length of the slant height as a radius. Here O dash D1 dash becomes the true length of the slant height because its image in the top view is parallel to the XY line. This is the required development of the lateral surface of a truncated pentagonal pyramid.
If you have any queries or doubts related to the present solved problem, you can mention it under comment section of this video. I'm happy to answer it as quickly as possible. For more videos on engineering graphics, visit the links provided under description of this video. Keep learning on knowledge sharing. Stay blessed. Thank you.